Our next lesson in geometry is called inductive reasoning. Our goals are to use inductive reasoning to draw reasonable conclusions and to identify statements as inductive or not inductive. Let's look at our vocabulary word. The process of making a general conclusion based on a specific sampling is inductive reasoning. Have you ever watched a commercial and they want you to buy a specific product, and since they give you a couple examples, and from those couple examples they want you to conclude that that's the only type of dish soap that you should buy or the only product that you should buy? That's inductive reasoning, because they're only showing you a couple examples. You can disprove inductive reasoning by a simple example. So the arguments made using inductive methods are probable, but it's not a fact. For example, sports provide good examples of the probable nature of inductive reasoning. An NFL running back ran for 1,000 yards in 3 consecutive seasons. Inductive reasoning would suggest that it was likely he would gain the same kind of yardage the next season, but he got hurt in the second game and his season was over. This is an example of what we mean when we say that inductive reasoning is probable but not inescapable. Okay? Let's try another example. Given a series, 2, 4, 8, what is the next number in the series? So if I give you a pattern, 2, 4, 8, what's the next number in the pattern? Well, we know to get from 2 to 4, we times it times 2. To get to 4 to 8, we times it times 2. So 8 times 2 is 16. We know it's 16. In reasoning this way, we assume we have sufficient information to see the correct pattern. What would the pattern be if an experiment showed the 4th term to be at 10 and the 5th term to be at 20? Yeah, if we showed that these are the next two numbers, then it would have to be times 2, right? The point is, inductive methods are based on probability. They are very helpful, but the conclusions in this type of reasoning are not inescapable. Okay? So let's go ahead and get our notes before I get too far ahead of myself. Go ahead and write today's date. The name of this lesson is called Inductive Reasoning. Okay. Sarah looks in several blackbirds' nests and comes to the conclusion that all blackbirds' eggs are speckled. Okay, that's inductive reasoning, because you're basing your decision off a couple examples. So inductive reasoning is basing your conclusions off of 2 or 3, I'm going to put samples. That's inductive reasoning. Here's another one. The boys present at a meeting of their club give their ages as, you don't have to write this down. One of them is 11, one's 12, there's 2 more 11-year-olds and a 13-year-old. There's 3 more 12-year-olds. an 11-year-old, and another 12-year-old. These are their ages. Frank comes to the conclusion that all boys in this club are at least 11 years old. Okay? And, of course, we can prove this false by another boy walking in and he's 10. Okay? Because he based his decision on just the few people that were there. Okay, let's do a different one. Steve looks at 20 pennies and sees Lincoln's head on them. He concludes that all pennies are Lincoln-headed pennies. Okay, it's not whether the statement is true or false, it's how he came to the conclusion. He came to the conclusion just based on the pennies that he had. Here's another one. A scientist mixes two chemicals and the mixture turns green. He does this mixture 25 more times, and each time the mixture turns green. He comes to the conclusion that when those two chemicals are mixed, they will always turn green. Okay, that's inductive reasoning. What he's not considering in this is what was the ratio of the mixture. If the first one, if he's mixing them evenly and they turn green, but what if he puts most of one and just maybe a cupful of the other? Is it still going to turn green? So you can disprove it, because if you do it that way and it turns another color, then you've disproved it. So this isn't taking into consideration how much of each chemical he's using. Let's do another one. Eric measured the three angles of several triangles and found that when he added the three measures, the sum was always 180 degrees. He concludes that the sum of three angles of every triangle is 180 degrees. Okay. So this again is inductive reasoning, because he came to the conclusion by doing it a few times or seeing a few of them, and he based his conclusion on just a few samples. Okay. You have used inductive reasoning all of your life. As a small child, you thought inductively when you decided that touching a hot stove would burn you. Now you think inductively when you decide, after many trials, which of two fast food stores makes the best hamburgers and fries. Inductive thinking happens when you observe individual events and then conclude a general principle. We cannot always be sure that a conclusion reached by inductive reasoning is correct. Sometimes we can check every example and then we know the conclusion is correct. However, if we cannot check every example, which is usually the case, you usually can't, we cannot be sure that the conclusion is correct. If we can find one example, called a counterexample, that does not agree with the conclusion, we know the conclusion is not correct. Okay, so a counterexample is the example that doesn't agree with the conclusion. So if you can find one example that proves it false, we know that it's false, that example is called the counterexample. Okay. Statement. Only Maris and Ruth hit more than 59 home runs. And then McGuire gets up and he hits 69 home runs. So he just proved that wrong. He was the counterexample. Statement. No one has played in more consecutive games than Cal Ripken Jr. Okay. And then you look and you find that someone plays in more consecutive games than Cal Ripken Jr. You've just proved it wrong. So in order to find a counterexample, you just need to find one example that shows the conclusion is not true. That is called the counterexample, the one that shows that it's not true. Okay, so to summarize, inductive reasoning takes some limited specific observations and arrives at a general conclusion. That conclusion cannot be proven to occur every time, because that would be deductive reasoning. You will learn about deductive reasoning in a few minutes. Okay? So let's look at some of these and see if we understand what we learned today. Okay, here we go. Okay, I want to know if this is inductive reasoning. I don't want to know if the statement's true or false. I just want to know if we used inductive reasoning to get the conclusion. Okay? For example, number 1. True or false? This is an example of inductive reasoning. You observe that it has rained on the past 3 Tuesdays, and you conclude that it rains every Tuesday. Is that inductive reasoning? Yes, that's inductive reasoning, because you base it on 3 examples. Okay. Is this an example of inductive reasoning? In your study of geometry, you notice that every square you have seen is also a rectangle. You conclude that this is true in all cases. Is that inductive reasoning? Yes, that's still inductive reasoning. Okay. So let's say that I have, okay, this is number 5. This is what I have. I have 7 minus 3 equals 4. 8 minus 5 equals 3. 9 minus 8 equals 1. Alright. My conclusion is the difference of 2 positive numbers is always positive. So my conclusion, I'm going to say the difference of 2 positive numbers is always positive. Okay, I want you to stop the tape and I want you to come up with a counterexample to prove me wrong. Okay? Okay, well, here we go. Well, let's do this. Let's do 3 minus 4 equals, well, when I subtract, I have to use the sign of the larger number. My larger number is 4 and it's negative. 4 minus 3 is 1. So these are both positive, but when I subtracted them, I did not come up with a positive number. So this is my counterexample. Alright? It's important that you try to do this before you watch me do it, because in a minute you're going to be doing them by yourself. So this shows you if you're understanding it or not. Okay? Let's look at number 7. Number 7 says 5 is greater than 0, 6 is greater than 0, 12 is greater than 0. Okay, conclusion. All numbers, I'm going to abbreviate numbers, that means numbers. All numbers are greater than 0. Okay, now I want you to stop the tape and I want you to come up with a counterexample. Alright. Well, a counterexample, all you have to do is come up with a number that's not greater than 0, right? -5. Okay? Any negative number would have worked there. In fact, you could have even put 0, because 0 is not greater than 0, right? So even if you put 0 there, you would have been correct. Okay, here we go. I'm going to give you a statement. I want you to give me a conclusion that seems reasonable. Okay? Okay. This is number 9, by the way. Number 9 says, I'm not going to write this down. You eat a new kind of fruit and suffer from hives for the first time in your life. A week later, you try the fruit and the hives reoccur. A month later, you try it again and the hives reoccur. What is your conclusion? You eat a new kind of fruit and suffer from hives for the first time in your life. A week later, you try the fruit and hives reoccur. A month later, you have a similar experience. What is your conclusion? Stop the tape and write your conclusion, and then compare it with mine. Okay. Well, just from inductive reasoning, I could say, well, you're allergic to the fruit, right? That would be one possibility. Okay. Let's go to number 11. In fact, I'm going to stop right there. Go ahead and stop the tape and finish this lesson.